Hello friends, after doing many of the applications on the De Moivre's theorem, now today we are discussing about the expansions of sine and theta and cos and theta, right? So how will you find the expansions of sine and theta and cos and theta in the terms of sine theta and cos theta itself? That can be possible with the help of De Moivre's theorem again. So I am starting with this topic, the expansions of sine and theta and cos and theta. How will you find this kind of expansion? Suppose we have cos n theta plus iota sine of n theta, which can be expressed in terms of cos theta plus iota sine theta raised to the power n by using De Moivre's theorem, right? Because cos theta plus iota sine theta raised to the power n is equals to this, so we can take it as in reverse order. So cos of n theta plus iota sine of n theta may expressed in this form. After that, we have to use the binomial expansion. What is the binomial expansion? What is the binomial expansion? Suppose we have x plus y raised to the power n. We can write it as nc0 x raised to the power n, nc1 x raised to the power n minus 1 y, nc2 x raised to the power n minus 2 y square. In this way, ncn y raised to the power n. This is our बाइनोमियल एक्सपेंशन, राइट? तो बाइनोमियल एक्सपेंशन हमारा ये होता है, इसी तरीके से आपको इसको भी सॉल्व करना है. तो cos थीटा प्लस आइटा साइन थीटा रेज टू द पावर n, इसको आप डिफाइन कैसे करेंगे? तो cos nc0 cos टू द पावर n थीटा, nc1 cos टू द पावर n minus 1 theta, iota sin theta, and nc2 cos to the power n minus 2 theta, iota sin theta whole square, plus nc3 cos of n minus 3 theta, iota sin theta cube. In this way, ncn minus 1 cos raised to the power theta, iota sin theta raised to the power n minus 1, plus ncn iota sin theta raised to the power n. This is our binomial expansion of this side, because x plus y raised to the power n is x, nc0 is 1, we know. So it is cos n theta plus nc1 cos of n minus 1 theta. This is y iota sin theta. After that, nc2 cos of n minus 2 theta, that is x to the power n minus 2 theta, and this is y square, plus nc3 cos of n minus 3 theta iota sin of theta cube, and so on. So in this way, we can use the binomial expansion. After using the binomial expansion, what will you do? You have to do that cos of n theta. Suppose here it is cos of n theta. It contains no any imaginary number like iota. It is a real part, right? So it is a real part. Similarly, iota square will be minus 1 and iota to the power 4 will be 1. So in this way, alternating terms you have to consider. This term, and after that it may be at the last, right? We don't know about the index of n, whether n is even or odd, right? So if n is even number, so it may be possible here will be iota and here is no iota, and if n is odd, there will be iota or no iota. So it is an issue when n is even number or odd number, right? So first of all, excluding this concept, we are just taking the expansion. So you have to consider these values like cos of n theta plus iota square will be minus 1. So minus nc2 cos raised to the power n minus 2 theta and sine square theta. Then nc4 cos raised to the power n minus 4 theta, sine to the power 4 theta, and so on. This will be our expansion which contains the real part up to n terms. Okay, I am writing here up to n terms. Similarly, we can find this is iota, and next one is also iota cube becomes minus iota. So in this way we can separate the terms which are containing iota. So it is an imaginary part we are taking here, nc1 cos of n minus 1 theta sine theta, and this is nc3 minus iota. nc3 iota is outside of this bracket, and that is cos of n minus 3 theta sine cube theta plus nc5 cos to the power n minus 5 theta sine to the power 5 theta. In this way, we can find out the imaginary part of right hand side. So this is a real part of the complex number and it is imaginary part of the complex number, and we know that. And we know that this real part cos of n theta is equals to this real part, and this imaginary part, this sine of n theta is the imaginary part which is equals to this. So when two complex number are equal, then their real and imaginary part are separately equal. So we can take as cos of n theta is equals to cos to the power n theta minus nc2 cos to the power n minus 2 theta sine square theta nc4 cos to the power n minus 4 theta sine 4 theta plus up to last. And similarly, sine of n theta will be nc1 cos of n minus 1 theta sine theta minus nc3 cos of n minus 3 theta sine cube theta nc3 cos of n minus 5 theta sine 5 theta. So these are the very beautiful expansions which we have to use in our other kind of questions, in which some questions are given like find the expansion of cos 5 theta, find the expansion of sin 6 theta. तो ऐसे questions में आप क्या करेंगे, आप इस तरीके से इस process को use करेंगे and then we can find the expansions of those which are in the form of cos of n theta and sin of n theta with the help of De Mor's theorem. And now again, if we divide these two expansions, suppose we are dividing sine n theta by cos n theta, what will happen? We know that sine n theta upon cos n theta becomes tangent of n theta. So we can find the expansion of tan n theta from here. Like we can take tangent of n theta also in terms of sine and cos. That is tan n theta is equals to sine upon cos, right? So you should write nc1 cos of n minus 1 theta sine theta minus nc3 cos of n minus 3 sine cube theta and so on. That is the numerator. And in the denominator, we have cos to the power n theta nc2 cos to the power n minus 2 theta sine square theta nc4 cos to the power n minus 4 theta sine to the power 4 theta and so on. So in this way, we can find the expansions of tangent and theta also in terms of sine and cos. If you want to convert this expansion in terms of tangent, so we can define it also with the help of tangent. That will we do further in our questions, right? How to find the expansions of tangent 4 theta, tangent 5 theta. That will we do after some time. So suppose here we need the expansions of cos n theta plus iota sin n theta. What will you do? That you have to do cos theta plus iota sin theta raised to the power n. After that, using the binomial expansion, and after using binomial expansion, De Morris, then binomial. After using the binomial expression, separate the imaginary and the real parts, then comparing on both sides, right? So we can generate cos of n theta and sine of n theta, and later we can find the tangent of n theta. So on the behalf of this article, we can find out some questions also, obtain the values of cos 5 theta, sine 5 theta also. So I am discussing one example. Suppose we have find the expansion of sine 5 theta, cos 5 theta, tan 5 theta, and value of sine 5 theta upon sine theta. So I am taking a general question which will show four kind of things. Like we can find the sine 5 theta, cos 5 theta, tan 5 theta, value of sine 5 theta upon sine theta. तो इस टाइप के जो क्वेश्चंस आपको एक्सरसाइज में दिखाई दें, तो उसके लिए आप किस तरीके से करेंगे? फर्स्ट ऑफ ऑल वी शुड अप्लाई द De Morris theorem and we have to start from that thing जो आपसे पूछा गया है. आपसे पूछा गया है साइन ऑफ 5 थीटा, कॉस ऑफ 5 थीटा, तो आपने यहीं से स्टार्ट करना है क्वेश्चन को, ठीक है? तो आप स्टार्ट करेंगे. सपोज वी हैव कॉस ऑफ 5 थीटा plus iota sine of 5 theta, that is cos theta plus iota sine theta raised to the power 5, right? So this is equal to cos of 5 theta NC1, that is 5C1 cos 4 theta iota sine theta, and after that it is 5C2 cos to the power 3 theta iota sine theta whole square, 5C3 cos square theta iota sine theta cube, 5C4 cos theta iota sine theta raised to the power 4, and 5C5 cos theta is not there, iota sine theta raised to the power 5. So in this way, we can use the binomial expansion. After using the binomial expansion, we can check how many terms are there which does not contains iota. Like iota square will be -1, and here iota to the power 4 becomes 1. एंड जो आपके पास ये वाली टर्म्स है, इसमें भी आयोटा आएगा, इसमें भी आयोटा आएगा और इसमें भी आयोटा आएगा, तो इसको हम अलग से ले लेंगे. तो वी आर टेकिंग दिस वन cos 5 theta, and next is 5c2 iota square is -1, 5c2 cos cube theta and sin square theta, and next one is 5c4, that is with plus sign, cos theta sine raised to the power 4 theta. This is our real part plus iota, taking the imaginary part, that is 5c1 cos raised to the power 4 theta sine theta, and plus minus 5c2, that is our 5c3, sorry, 5c3. Iota square is -1, iota is outside of this bracket, so that becomes iota cube. Iota square is -1, so I am taking minus sign here. 5c3 cos square theta sine cube theta, and at last one 5c5 sine to the power 5 theta. This is our imaginary part. After taking the real and the imaginary part, comparing this with the left hand side, we have cos 5 theta is equals to cos to the power 5 theta 5c2 cos cube theta sine square theta 5c4 cos theta sine to the power 4 theta, and sine 5 theta becomes, that is 5c1 cos raised to the power 4 theta with sine theta, 5c3 cos square theta with sine cube theta, plus 5c5 sine raised to the power 5 theta. So we have these two expansions, cos 5 theta and sine 5 theta. After getting these two expansions, now we have solved these two. After that, we need tangent of 5 theta. So what will happen? Tangent of 5 theta becomes, you have to dividing sine 5 theta by cos 5 theta. So we have 5c1 cos raised to the power 4 theta sine theta, 5c3 cos square theta sine square theta, 5c5 sine raised to the power 5 theta, dividing by cos raised to the power 5 theta, 5c2 cos cube theta sine square theta, 5c4 cos theta sine to the power 4 theta. In this way, we can find out the expansion of tangent of 5 theta in terms of sine and cos. Whenever you divide this whole expression, numerator and denominator, with the cos of 5 theta, dividing the numerator and denominator with the help of cos raised to the power 5 theta, what will happen? 5c1, that becomes tangent of theta, minus 5c3 tangent square theta, 5c5 tangent to the power 5 theta, and in the denominator we have 1, 5c2 cos to the power 5 से divide करेंगे तो tan square theta plus 5c4 tangent to the power 4 theta. Now we get this one, that is tangent of 5 theta. So tangent of 5 theta becomes this in terms of tangent theta, right? So we have find out the expression, this tangent 5 theta, cos 5 theta, sine 5 theta, and last one is how will you find sine of 5 theta upon sine theta? There is nothing, just you have to take common. This is sine 5 theta. From this expansion, we can common sine theta. You can see each term have sine theta, take the sine theta common and shift on the left hand side. We can obtain sine 5 theta dividing by sine theta is equals to 5c1 cos 4 theta minus 5c3 cos theta and plus 5c5. Sorry, here sine also sine cube theta and plus 5c5 sine raised to the power 5 theta. So in this way, we can find the expansion of sine 5 theta upon sine theta after taking sine theta common from here. So in this way, we can find out the different kind of expansions of sine n theta and cos n theta along with tangent of n theta also, like where n is any integral number. So we can use that De Moivre's theorem with the binomial theorem, right? So with a combination of De Moivre's and binomial theorem, we can find the expansions of sine of any multiple with theta, right? N theta or cos of n theta, tangent of n theta. This is also a beautiful uh, combination and also a beautiful concept of taking the expansions uh, from the De Moivre's theorem, right? So we are coming in our next video with some more applications on the De Moivre's theorem. Please watch on regular basis. Thank you for subscribing and watching our channel. Thank you.